So starting off, we've got a sample size of 33, and we've got 19 who said yes. So my p hat is going to be 19 out of 33, and I want to come up with a hypothesis test to see if the students or the households at our high school are different than the rest of the country. So there's 4 steps. I noted them on here. There's step 1, step 2, step 3, and step 4. But even if I don't note them on there, you got to do those 4 things to justify the work that you get. So when I set up the hypotheses, what is the first part? HO is what? So it's a proportion problem. I probably want to use P. I don't know that if I'd quibble with you if you used a mu on there, but really it's a proportion, so you ought to use a P. And the alternative hypothesis, because we want to know if the people here are different, I'm going to use a two-sided not equal to test. And there's one other part that I've got to do for a proportion problem or for a hypothesis. Say what P is. So where P, and this is kind of important because P is the proportion of what? Homes of this school that have the Super Bowl on. I already know what it was for the country. It was 41%. It's homes at this school. So P is the proportion of homes at CSHS with the Super Bowl on. And that's approximately 25% of your grade for that problem. So step 2 is to do the conditions. There's 3 of them. Just generically speaking, what are my 3 conditions? Now, this isn't going to be sufficient, but what are the 3 conditions? Random sample, normality, and 10% rule. So I don't mind if you write this just to give you an idea of what you're talking about, but now we need to see, are these 3 things met with the data in the problem? So first of all, do I have a random sample? I hope it's a random sample, but I just asked students in this class. So what I hope is that you guys are like a random sample of students at this school. I hope this class is like a random sample of households at this school. Because if you're not like a random sample, then I've got cruddy data and I could just throw the whole thing out. But nevertheless, I'll keep working. I'm not going to stop working just because I'm not quite sure if this condition is met. So what's the key to getting normality? Large counts. And how does large counts look with proportions? Here's where I've got 10 successes and 10 failures. Do I? Yes, I do. I have at least 10 successes and 10 failures. And that was 19 successes and 14 failures. So large counts says the sampling distribution is approximately normal. Now, do you have to write that second sentence? I don't know. I don't want to get caught up in, do I have to write this? Do I have to write that? The whole idea is that you're writing a persuasive paper persuading me or the grader on the AP test that you deserve credit for the class. That's the whole idea. So when you demonstrate more understanding of what's going on, you're more persuasive. So that's a good deal. Now, I'm not going to get into this too much at this point. Really, that's the condition for a confidence interval. For a hypothesis test, we say I had 33 households and I expected 41.7% of them to say yes and the other 58.3% of them to say no. And is that number going to be more than 10? I'm not splitting hairs on that at this point in the curriculum. And the third thing is the 10% rule. So I need the 33 households I sampled to be less than 10% of the houses at this school. Clearly, there's more than 330 households at this school. And so I'm going to write it exactly like that. Clearly, there are more than 330 households at CSHS. And that's the next 25% approximately of the grading on that. So some would argue we really haven't done any math yet, but we've already accounted for half of the grade. Okay, this is all critical lead up to justifying the mathematics. So now we're to the mathematical part. What should you start with? A picture. So make me a picture. The center of the picture is the 0.417. Then if I grab my calculator, I see that 19 divided by 33 is 57.6 or 0.576. I've got another fence over here on this side, and so to kind of figure that out, I'm seeing how far they are apart, and then I'm going to go that distance again to get 0.258. And again, the idea is that this distance and this distance need to be the same. So I figured out what that one distance was and then did it from the other side. And the standard deviation of this problem, this distance, the standard deviation for a proportion problem is going to be the square root of p times 1 minus p over n, or 0.417, 1 minus 0.417 over the 33 households we sampled. And I like to take that value, that 0.085, and store it in my calculator. So that distance is 0.0858. Now I've got a two-sided problem, so the p-value is going to be both sides. So the p-value is 2 times the probability that we get a p-hat bigger than the 19 out of 33 that we got. So then I'm going to standardize that. So 2 times the probability z is greater than 19 out of 33, and you could convert that to a decimal if you want, over 0.417. I actually prefer to write the whole thing without having used my calculator first, personally, so mine would look like this. And then I've got, whoop, do that here. $1.85. Okay, so this is my test statistic, 1.85. I'm going to use my calculator and say normal distribution or normal CDF of that answer I just got, which was 1.85 or whatever it had with the decimals, infinity, 0, and 1. Paste that in. I could also use my chart to figure this out, and this tells me 2 times 0.0322. So I double that, and this right here that I just found is the p-value. So mathematically, there's the steps you have to do. And then the final step, step 4, is assessing that p-value and telling me what you think. So do you think that p-value is small? No? Okay, so if you don't think it's small, what am I going to do? So if it's low, I reject HO. We don't think it's low, we're going to fail to reject HO. So here's what I'm going to write. Since my p-value is not that small, and then I'm going to tell you what it is in case somebody else has a different idea of what small is. I will fail to reject HO in favor of HA. Now, if we had been given an alpha level, we would compare that p-value to the alpha level. But I wasn't given an alpha level, so I'm just going to use my own brain and decide that's not that small. So I'm going to fail to reject HO in favor of HA, and I'm going to say that is, not that is, I continue to believe the households at CSHS watch the game similarly to the rest of the country. Another way of saying it is, I find insufficient evidence to decide that this school is different than the rest of the country. I continue to believe we're just like everybody else in this regard. Now, I want to ask you a couple of questions about this. So here's my question. What if at the outset I said, this is Texas. I bet people around here watch the Super Bowl more than the rest of the country because we love football here in Texas. And so I got the same data. Would anything on this green part change? Yes. What would change? This HA would change to a greater than. Do I have evidence we watched it more? Okay, would anything on this blue part change? No, nothing here would change. How about my picture? Yes. What changes? It's only one-sided. It's only over here. So I don't double it. So now my my p-value would be 0.0322. Now, we might think that's small. A typical good alpha level is 0.05, unless one's given to you. So now I think it's small. Now I reject HO. I do have sufficient evidence that we watch it more than the rest of the country. All the time when you do a proportion problem, it's a Z problem, which means there's no degrees of freedom. That's only, for now, that's only with T. We'll use it some other places later. But the Z curve, the normal curve, does not have degrees of freedom. So there is a two-sided hypothesis test for proportions.